Morning, doctor. So today I will be presenting analog and digital modulation techniques. So the primary objective of modulation is the reliable transfer of information from a source to a destination through a physical channel. So first importance of modulation, practical antenna size. By superimposing the low frequency message signal onto a high frequency carrier signal, modulation solves the physically impossible antenna height. Next, multiplexing frequency division. Because without modulation, all voice and music signals will occupy the same low frequency baseband. So modulation allows us to shift different signals to different carrier frequencies, allowing them to share same physical medium without interference. Next, noise immunity and range. Certain modulation techniques allow the receiver to filter out the noise that accumulates during transmission, recovering a clean signal at the destination. So analog vs digital modulation. In analog modulation, the carrier wave parameters like amplitude, frequency, phase are varied continuously in direct proportion to the analog message signal. The output is a continuous waveform like this. So the examples are AM and FM radio and analog TV. Digital modulation, the carrier wave is switched between a finite set of discrete states, such as specific fixed amplitude or phase angles, to represent binary data, zeros and ones. So the example will be Wi-Fi and 4G or 5G cellular. So these are the digital signals. So let's go to section 1, analog modulation. AM, amplitude modulation of analog modulation. This is the standard AM equation, where this is the unmodulated carrier amplitude, and this represents the modulation index. If modulation index lower or equals to 1, efficient transmission without distortion. If it is more than 1, over modulation occurs, causing severe distortion in the demodulated signal. So let's talk about the modulator circuit of AM, which is square law modulator. It utilizes a non-linear device, typically a diode or a FET, operated in its non-linear region. The carriers CT, as you can see in the circuit in the block diagram, the carriers CT and MT are summed to create a V in, and then the diode's current voltage characteristic is approximated by Taylor series. After that, the square term V square produces cross product, and this cross product mathematically represents the AM. And then finally, the output current is passed through a bandpass filter, and this filter rejects the baseband frequencies and the second harmonics, allowing only the AM signal to pass. Next, let's talk about demodulator circuit of AM, which is envelope detector. It consists of a diode connected in series with a parallel resistor and capacitor, as you can see here. So it will first go through a charging phase and then a discharging phase. And then when we go to the whole mechanism, the capacitor discharges through the load resistor RL at a rate determined by torque equals to RLC. And then it will, for distortion-free demodulation, the RC time constant must satisfy this formula. So if RC is too large, diagonal clipping occurs. If it's too small, excessive ripples will appear in the output. Next, FM, frequency modulation of analog modulation. So this is the standard equation of FM. It offers superior noise immunity by keeping the amplitude constant, and the information is encoded in the rate of 0 crossings. According to Carson's rule, the bandwidth of FM is approximately this formula. So the delta F here is the peak frequency deviation. This indicates FM trades bandwidth for signal quality. So this is the modulator circuit of FM, which is varactor diode VCO. As you can see here, PN junction diode to operate in reverse bias. So when the diode is reverse bias, a depletion region will form, acting as a dielectric. And then message signal voltage increase, depletion region widens. And then capacitance decrease, and it will directly modulate the frequency. Next, the modulator circuit of FM, which is slot detector. So as you can see from this circuit diagram, the LC tank is tuned to a frequency slightly offset from the carrier. So incoming FM signal falls on the linear slope of the frequency response curve. As frequency varies, the circuit gains will change, and then converting frequency variation into amplitude variation. These are then detected by the standard envelope detector, and this is the final waveform. Section 2, let's talk about digital modulation. So what is ASK? Working principle, ASK is the digital equivalent of AM. Amplitude of the carrier is switched between two levels to represent binary logic, which is this 1 and 2, 1 and 0, like that. So next, modulator circuit of ASK, which is emitter follower switch. As you can see here, this is a BJT, and then simple modulator uses this NPN transistor. And the carrier is applied to base the binary data bias the collector. When data bit is 1, transistor is based into its active region, passing the carrier. And when the bit is 0, transistor enters cutoff and will block the signal. The demodulator circuit of ASK is threshold detection, which is an envelope detector followed by a comparator. As you can see from this block diagram, this comparator compares the voltage against a reference, which is Vref. When V in over Vref, the output logic is 1, and it will remove noise that falls below the threshold, and is a key advantage over analog AM. So let's talk about another digital modulation, which is BPSK. So BPSK represents data by shifting the phase of the carrier by 180 degrees. It robust against additive noise, which is bit 1, phase 0, bit 0, phase 180 degrees. So this is the modulator circuit of BPSK, double balance mixer ring modulator. As you can see from this circuit diagram, it is a transformer coupled circuit utilizing a ring of 4 diodes. So when positive cycle, diodes D1 and D2 conduct. When negative cycle, diodes D3 and D4 conduct, reversing the connection to output transformer. So this mathematical inversion is equivalent to a 180-degree phase shift. The demodulated circuit of BPSK is Coastal loop. Coastal loop requires a coherent detector because the phase information is relative. As you can see from this circuit diagram, the Coastal loop splits the input into in-phase and quadrature paths. It multiplies the input by a local oscillator, and then error voltage from the product of the I and Q arms is used to keep the local oscillator perfectly locked to the incoming carrier frequency and phase, allowing for accurate data recovery. Let's compare the analog and digital techniques. So for bandwidth, AM is bandwidth efficient. FM will consume large bandwidth to gain noise immunity. Well, whereas digital modulation, basic BPSK has similar efficiency to AM. However, modern system using this MJIIT PSK to encode module bits per symbol, achieving throughputs far exceeding the analog limits. Noise resistance. For analog modulation, noise adds directly to the signal voltage, and FM limiters can remove amplitude noise, making the FM quieter. Whereas the digital modulation utilizes the threshold effect. As long as noise does not exceed the threshold to flip a bit, the receiver can reconstruct the data perfectly. Circuit complexity. For analog modulation, circuits are simple and using passive components R, L, and C. It is low cost, but it will sometimes aging and temperature drift. For digital modulation, it is complex and requiring synchronization, but they offer high stability and reconfigurability via the software. And last, practical applications comparison. For analog modulation, it is still dominant in applications where cost, simplicity, and latency are the primary concerns. For an example, aviation. Legacy AM is used for pilot-to-tower communication because it is strictly real-time and allow multiple simultaneous transmission to be heard without one blocking the other. Whereas the digital modulation is required for all modern applications where data integrity, security, and integration with computers are necessary. Example, 4G and 5G networks. It uses complex digital schemes like QAM to deliver high-speed data that analog cannot handle. Thank you. This is my presentation.